Modular reconfigurable multirotor systems can adapt to various tasks and payloads by changing their configuration. These systems are typically designed with interchangeable modules that are assembled side by side to form two-dimensional array configurations. As more modules are added to an array, its relative thickness with respect to its size decreases, resulting in a diminishing structural integrity because of higher bending moments and larger deformations. In addition, with polygon-shaped modules placed in the same plane, the individual thrust vectors they generate all point in the same direction. But orienting modules in different directions would be desirable. For instance, to create more agile platforms or 6 degrees of freedom systems that can be used for object manipulation. To address these limitations, we introduced the Dodecacopter, a modular multi-rotor system whose modules take the shape of regular dodecahedron. We developed an assembly method that allows us to orient modules in different directions, but also to create various three-dimensional configurations. Standard configurations like quad rotors and hexarotors can be created with this system, as well as flat arrays. Three-dimensional configurations based on tetrahedral blocks can also be created. These configurations have the advantage of increased structural integrity while maintaining a high aerodynamic efficiency from the absence of directly overlapping modules. The possible module orientations offered by the Dodecahedron-Shaped allow the assembly of 6 degrees of freedom systems, which in theory can independently control their position and orientation in space. In our work, we examined and optimized the control and structural properties of these systems, leveraging concepts from convex and mixed integer programming. A prototype of the dodecahedron was built and tested in multiple configurations to validate the assembly method and feasibility of the proposed system. The configurations that were tested include a quad rotor vehicle, a hexarotor in a rotor out situation, various tetrahedron configurations with 4, 10, and 16 modules, as well as a 6 degree of freedom hexarotor.